The opinions expressed are those of the participants and do not necessarily reflect the official positions of the sponsors, advertisers, or presenters. Advertising does not imply endorsement by the sponsors and presenters.
Hey guys, and welcome back to Lighting Controls Podcast. We have another fantastic guest for you today, but before we jump into the conversation, let me take a minute to remind everyone, today's episode is presented by the LCA, the Lighting Controls Academy.
And is financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website, lightingcontrolspodcast.com. Got all of our episodes and a whole lot more. But a huge shout out to our sponsor for this episode. We cannot do this without your support. MaxLight and their C-Max Lighting Controls platform, which is simple, versatile, future-ready, and scalable. And I'm not just reading that off their website. I mean it. It is a really cool resource that you should definitely check out if you're unfamiliar with it. They have a patented USB-C connector on their controls ready luminaires that gives you that flexibility to basically plug and play your lighting controls, going from basic, non-connected, non-communicating devices all the way up through networked lighting control solutions for your entire building. I really recommend you check them out, maxlite.com/CMAX. But let's get into the conversation. So today we have Bolis. Bolis, do you mind just giving us a quick breakdown on who you are and what you do?
For sure, thanks. So Bolis Ibrahim. I am an entrepreneur and electrical engineer and inventor. I been in the direct current power distribution space for more than a decade now. So building direct current power distribution systems in research labs and commercially. And I co-founded a company called Argentum Electronics, which later on merged with another player in the space to create Sense Power, which is where I'm at right now as the president, leading the commercialization of direct current power technologies for the lighting industry, for telecom, and for data centers.
Well, thanks for joining us. I think this is a topic that has come up a couple of times in podcasts in the past, and it's really great to have somebody who actually knows what they're talking about when it comes to this, because it is fascinating kind of technology.
Yeah.
And I'm curious if you mind just giving us a little bit of a explanation for what DC power is and how it compares to the standard line voltage power distribution in a building.
Oh, for sure. Yeah. So I think we can take a step back in time to like the days of like the early days of electricity, and like we can think of Westinghouse and General Electric, and that's like Tesla and Edison, right? And so so at the time, this was like very early days of electricity. Edison there was a race to deliver power, generate it, but also distribute it. And so at the time, we only had direct current power. And the problem with direct current power was we had a tough time getting it to step up to higher voltages. And so Edison had a hard time sending it long distances, because in order to send power long distances, practically, we're better off sending it at very high voltages and very low currents. So if you took physics 101 is Ohm's law. So the higher the voltage, the lower the current, and this is the power law. So the higher the voltage, the lower the current, the same amount of power. And the key with higher voltage and lower current is that the power loss on a cable is just determined by the current. So it's I squared R. So the resistance of the cable times the square of the current. And so by reducing the current and increasing the voltage, I can lose less power on a conductor. So that's voltage drop. Any power loss is going to be voltage drop. And then I can send it very far and still have a usable voltage at the other end. And what happened is that Tesla had been working for Edison and then left and went to work for Westinghouse. And they came up with the AC system. I'm oversimplifying here, and there's a lot more to the story, but essentially what we could do like 150 years ago that we could do today. So 150 years ago, the only way we had to change voltage levels that was cost effective was a transformer. And we still use them today. They're just two coils of wire around an iron core. But in order to use a transformer, it has to be AC. can't use DC with a transformer.
Mm-hmm.
You need an alternating current to make that transformer do what it needs to do to step up or down the voltage. And so Edison lost. But fast forward to today, and we live in a world where all our consumption is direct current, almost everything.
Right.
So LED lights, so incandescents, they work both ways. Fluorescent, again, the way a fluorescent worked initially was we had these like really heavy ballasts. If you ever picked up a fluorescent ballast from like back in the day, it was heavy, it was an iron core, it's a transformer. And then there were electronic ballasts. So electronic ballasts convert the AC coming into DC and then change it to a higher frequency, step up the voltage like that. They're much lighter weight. And so that's an electronic ballast, which the same principle of an electronic ballast is what we use in our cell phone chargers, laptop chargers, all these like bricks that we plug into the wall. And we only do that because all our consumption is direct current. So LEDs are direct current. Right now, I'm talking to you through a computer. That's all direct current. Right. Anything digital, anything with a screen, anything with a battery, we store direct current in a chemical potential, right? Solar panels produce direct current. EVs, level 3 fast charging, that's a DC fast charge. Modern HVAC equipment, so we hear all this like variable frequency drive, variable refrigerant flow, VRF, VFD, anything variable, that's a DC brushless DC motor. So we live in a world that's today all DC, all direct current. But the utilities are still sending us AC. So what do? We convert the power with a driver, right? Like we have like our, like if you think in the context of lighting, we have LED drivers. And LED drivers are not so great because they are the first point of failure in an LED system. They're always the first thing to go, and they have to be changed. And they create flicker. Like if you've ever seen an LED flicker or just shut off, that's a failure of the driver.
Yeah,
so if
like
you're ever
we
driving
see that
down,
a lot. Yeah, exactly. Street lights that are flickering.
Yep.
Oh yeah. Or signs. You always see like one letter on like someone's sign, just, like the one letter flashing.
Yep.
Right. So I mean, basically, because we are predominantly DC power for all of our consumer electronics and the majority of the building's electronics that support the systems, the question then becomes, well, why aren't we just having DC power everywhere, and so we don't have to transform or convert from AC to DC?
Yeah, and it's a good question. It's like if you think of the construction value chain, like where these decisions are made and how they're made and why they're made. So there are a few things. One of them is momentum of thought. So like we have a way that we do things, and it's easier to just keep doing things the way we're doing things. It's harder to change from that unless there's something disruptive. And disruptive has to be like 10x better, 10x cheaper, right? It can't be more expensive, and it can't like be just twice as good. It has to be like way better, way cheaper. And so this is where DC power comes in, is that in the major benefits. So like we think of like, okay, like why do we do line voltage? It's because like number one, it's the way we do things, the way we've always been doing things. Like LED is actually quite recent if you think about it in the grand scheme of things.
Right.
It's only been like 10, 15 years where we've had like major like LED rollout in the last 10, 15 years. Before that, like we still have people have fluorescents that they're relamping.
Yep.
And so if like we're and we'll talk about like where DC works and where it doesn't, and like why it works and why it doesn't. So if the building, like we have plug loads, and those are mandated by code because we had a lot of things that had to go into the plug load. But now more and more everything is digital. It's USB-C. We're converting, and for the lights, it's a similar story. It's like we're using LED now, so we don't need as much power on these branch circuits that are overkill a lot of times. And if you think about places like California, we have more and more, we're creating smaller zones, like smaller power zones. And so this is where DC power can come in and help in cases of new construction. So because you're going to use different cabling for DC. So in line voltage, you're going to use, in most cases, 3 conductors. you have your line, your neutral, and your earth. Or if it's a line-to-line system, you're going to have 4 conductors. And those are going to be carried through some sort of conduit, mechanical protection, so like a pipe or a flex. Whereas DC, on the other hand, is 2-wire. It's positive and negative. You just have 2 wires.
Right.
And it's free air, right? So you treat it like you would network cable. So J hooks, cable trays, wire straps, etc. And so if you think about DC in that sense, you automatically go like, okay, it's probably not a relamping scenario. Like if you're going to relamp if you have an existing building and you're thinking like, oh, I have these fluorescents, I'm going to change the tubes to LED tubes. You're not going to change the wiring to DC. Your payback is going to, it's not going to work out. And maybe you need to change the fixtures. Even then, you can keep the same wiring. Where it works is if you're gutting the place, you're going to rewire anyway, or if it's a new construction. Then you think about like here now, it's like a clear opportunity is like I can eliminate all the mechanical protection. The code allows me to do that by maintaining a safety profile that DC or class 2 low voltage can allow for. And now I'm delivering power to the luminaire that it natively uses direct current. So I don't need to convert or rectify, we say, the AC into DC. So what I can eliminate is the driver. I can eliminate that from the equation. More importantly, I can eliminate, I don't know if you're going to see this, but this is an electrolytic capacitor. And this is the problem. And the electrolytic capacitor,
for those who are listening, it kind of looks like a battery.
Yeah. And if you've never touched one and zapped yourself, consider yourself lucky.
For sure. Yeah, these are kind of like they're kind of like batteries. They store energy. What they help do in a converter or rectifier is they help smooth out the AC and make it into a straight line for a DC. The problem with this is it's filled with a fluid. It's called an electrolyte. And the electrolyte, as this thing warms up, will vaporize and will escape through the leads where the pokey bits come out to connect to the circuit. And the electrolyte will vaporize and you lose that electrolyte. And then this thing will lose its ability to smooth out the AC, right? And what does that look like? Flicker. We see flicker. We see like the lights. Eventually, it'll fail completely, and the light will just shut off.
Right.
This is the problem, and the whole point of DC power. The idea is like removing these early points of failure, these lossy components. These rob the circuit of efficiency, and they allow us to decarbonize the construction by eliminating conduit and mechanical protection because their low voltage circuits are safe.
Now, so I have a question on that though. So
of course.
do you think the code would eventually change if people were truly starting to wire buildings with DC power? Do you think that the code would change, that it would require still some sort of conduit or protection to make sure that it is protected in the walls and things like that?
It's a good question. And so the code has changed in the opposite direction. So in 2023, the NEC in 2023 changed to add a new class of power. So for the first time in 45 years, I think it was 1978, we had class 3 in the NEC. What I'm referring to right now are class 2 low voltage circuits. Those are the class 2 low voltage circuits are ones that are under 100 watts or 100 VA and under 60 volts. And if you maintain those limits, you're allowed to use free air conductors because it's inherently safe. You're power limited at the source. What happened in 2023 was we saw the addition of class 4 because there was such an interest in utilizing DC more. And actually, I got to give kudos to our competitor VoltServer for being one of the pioneers in the space with a technology they call digital electricity. And what that got people doing is thinking at UL is like, how do we standardize this approach? And then eventually that got into the NEC as class 4 power, of which we're a manufacturer. So since we manufacture...
And just to help people who don't understand that term class 4, do you mind just giving a quick definition?
For sure. The easiest way to think about it is class 2 is power limited at the source. right? It's a power limited circuit. You only have 100 watts at the source for every branch circuit, right? And so no matter what you do, you're not going to cause a fire or cause an electric shock. It's 100 watts at 60 volts, right? Max. Class 4 is fault managed. It's not power limited. So instead of power limiting at the source, you power limit at the fault. So you have an unlimited amount of power, as much as the cable will carry. You respect the ampacity of the cable. But your voltage is capped at 450. So 450 volts is the current limit, the NEC class 4 limit. And what you got to do, what the manufacturers have to do, is ensure that the power at the fault is less than 100 watts, not the power at the source. So what that allows us to do is send practically, like we send 400 volts out. We respect the ampacity of the cable. So we could do up to 3 kVA or 3 kilowatts per pair of conductor. So per positive negative pair, 3 kilowatts. So we can have 3 kilowatt branch circuits at 400 volts DC, and that's 8 amps. So you can use 16.2, 14.2, right? Like it's like very thin conductors, free air, you get massive amounts of power. So the code is changing, but not in the direction of more mechanical protection, in the direction of more intelligent protection. Having systems that can intelligently protect without adding more carbon intense materials on the job site.
Yeah, and so I guess the question then becomes, since you have a higher voltage running down those lines to compensate, I'm assuming, for voltage loss, what do you do then to get it to the right voltage for an LED?
Oh, okay. So this comes and like if you take a step back in history and remember, like back in the day, the only way we had to step up and down voltages was transformers. Fast forward 21st century, we have switch mode power supplies, and we have transistors, and we have all these great digital devices that allow us to change voltages very efficiently using switch mode power supplies, which are DC to DC converters, which in some cases, like a constant current driver for an LED doesn't have or doesn't need electrolytic capacitors. And so at the fixture level, like this is like not something that exists today, but like I'm just riffing about like the future.
Sure.
Like right now, like the majority of these class 4 systems, there's only 3 of us really. It's like us, VoltServer, and Panduit with product on the market. It's a point to point. So it's a lot of telecom data center type applications, point to point. But eventually, one of us will come up with, and then the rest will follow, of a bus architecture, kind of like how we do AC. So the barrier to adoption for lighting is like we need a bus architecture. We need a way to be able to tap, drop down into each fixture, and each fixture will have a step down converter and a driver, a DC to DC driver though. So very similar to today, the way we do things today is just the idea is start off with DC and eliminate the need for mechanical protection.
Right. And so, I mean, from a form factor standpoint, if you're looking at it from a 10,000 foot view, really, there's not a whole lot changing if you're just looking at it box to box ratio. But in reality, the infrastructure is really the key element here that is being modified. And that actually is a significant change from what we're doing. It's almost like if we went in and said, okay, all of this 0 to 10 volts getting replaced by Dolly. It's like it's the exact same conductors we're using, but suddenly the infrastructure has completely changed to accommodate this new concept. And so when it comes to, this whole DC to DC conversion, it sounds like it's more at the building level that needs to be made, that decision needs to be made rather than at the lighting level.
Oh, for sure. This is and like even when we work with our agents, like we tell them like this is like if you wait until you get a drawings and you have to like a fixture schedule and you got to populate it, it's too late. It's done. Right. This has got to be like right at the jump with the specifier as when they're doing their single lines, because if you don't circuit it as DC, then no one's going to go back and redo all the work.
Right.
I mean, some people will, and kudos to those specifiers. You know who you are, shout out. But if you got to go back, it's like an uphill battle. Like, you got to start with the specifier from the jump and say, like, here's how you circuit this as a DC, a single line, versus a line voltage single line, right? And if it's class 2, you gotta have 100 VA branch circuits. If it's class 4, it's a little bit different. Versus if you're doing line voltage, everyone's thinking 15 amp, 20 amp branch circuits, 277, 208. So those are the small differences at the jump that have to be brought into the picture prior to even getting to the placement of luminaires. Because you're as you said, it doesn't for the lighting, it doesn't change anything. The lights are there. It's the power, the infrastructure that's changing.
So thinking about this, like crystal ball, looking into the future, you know, 2 years, 5 years, 10 years down the road, whatever you think, what is sort of like, because there's probably a lot of people listening thinking, okay, well, how do we potentially think about implementing this? So where do you see this going? How does this start to roll out? Where do you see it sort of taking off?
Cool. Yeah. I mean, so today, like we've done just us, like we've done over 2 million square feet of class 2 low voltage. And we're probably like 10% of the, like, there's probably like, I want to say, maybe this is bold, but I want to say there's probably 100 million square feet right now active of class 2 low voltage lighting. Some of that was PoE, and I'm sorry if you have a PoE system. Some people will like PoE. Look, PoE was a great. PoE was a great. It paved the way for people like us. It educated the market. I don't think you need a 1 gigabit capable data drop.
I want to press on that a little bit because I know a number of colleagues who
I'm gonna get in trouble.
PoE is the future.
I love PoE.
And
oh no.
The perspective here on this show is everything has its place.
100%.
And so where do you see DC power stepping above PoE?
Oh, okay. So PoE, of course, there's no better way to do powered delivery for things that require data. So security cameras, Wi-Fi routers, access points, like what else? IP telephones, although we're not really using much of that anymore. And so there are so many things. Sorry, Cisco. There are so many things that were PoE. Because they have all the patents.
Yeah, of course.
They do.
So there are things where PoE is a good fit. Now PoE for lighting, that was really interesting. And actually, we used to build a PoE lighting system, and then we changed it to be what we call ad hoc PoE. So it didn't follow the IEEE standard. And then eventually we just did away with the cable and made it cable agnostic. So you want to use PoE. You want to use like Cat5, use Cat5. You want to use 14.2, use 14.2, like whatever. We kept getting pressed by the contractors on like, we don't want to terminate cable.
Right.
So PoE has its place for sure. And in terms of the next like year, 2 years, there's going to be more PoE deployments. People are going to keep doing it.
Sure.
There's going to be more class 2 low voltage lighting. That's happening a lot, especially like California, Colorado, Arizona, like New York. Like we see a lot of this, a lot of interest in different areas, a lot in Canada as well. And so class 2 low voltage, that will continue to take off next 3 years. 5 years down is where we start seeing the mass adoption of multi-drop class 4, right? And so this is something that maybe comes out 2 years from now. It's like it builds up popularity, and then we see mass adoption of multi-drop or bus architecture class 4. Once we have a bus architecture class 4, then you're now, and the cost of that comes down to be the same cost as AC switchgear, so breakers, right? If you get a per circuit cost on the equipment side that's the same, it's a no-brainer because you have no mechanical protection, it's safer, it's more efficient, and it's DC. And so that's where it's bad news for maybe not bad news, it's good news. It's good news for the electrical industry that there is a a new, better, safer way to do things. And it's a pivotal moment in history because, and I'm crystal ball, so my crystal ball could be broken, but pivotal moment in history, this on the same scale, right, as Tesla versus Edison, like on that same scale, because like we're now shifting back to DC from an AC world, and it's not like, I don't think it's like everyone wakes up and one day it's like, oh shit. I think it happens over time. Like it's already like if you think of right now, if we need to do a long distance transmission from like over 600 kilometers, I think that's the break even distance for this. So over 600 kilometers, you have to go high voltage DC. You can't do a high voltage AC anymore. It doesn't work. So very long distance transmission is now also moving to HVDC. So, and if buildings are moving to DC and HV and long distance transmission, AC is getting stuck in the middle at the distribution grid. So like the community level distribution grids. And that's probably where it'll live for the next like 100 years until we squish that as well.
See, is there an opportunity here where contractors start fighting? Like, is this become like, are the low voltage contractors going to start fighting for some of this work moving forward, and the electricians are going to potentially get pushed out of some of this work? Because it's classified low voltage, right? Yeah. So do we start getting that power struggle?
It's a good question. And like before I did this, I worked at our family business, which is we're electrical contractors. And so my father's a master electrician and like his father and like our anyways. And so I always hear this, and I think it's a lot of like it's more applicable in the POE where you have like the data comms contractors versus the electrical, but low voltage is class 2 low voltage is covered in the National Electrical Code. That's something that electricians use and electrical contractors use to guide their installations. Like this is something that's well documented for electrical contractors. It's something that they do every day. They install low voltage circuits, class 2 low voltage circuits all the time. I think this is, to be honest, for sure, some jurisdictions allow for this work to be done by low voltage contractors. Some jurisdictions require that luminaires are installed by electrical contractors for fire safety purposes, because they know how to secure it back to structure.
Sure.
I think the NECA, like the National Electrical Contractors Association, is doing a good job educating their members. I think the major national electrical contractors are doing a fine job of integrating this into their workforce. I don't think this creates much of a struggle between the two, especially the way that we're doing it. Whereas it's not data comms infrastructure, it's electrical. I think it depends
And getting into data, I mean, the thing is, what we're talking about right now is just power. And unfortunately, in North America, we love 0 to 10 volt, which then also makes circuiting and zoning intrinsic to each other. Whereas, what we're talking about here, I imagine, is not using 0 to 10 volt or analog type control signals. It's using something a little bit more advanced than that.
So on the control side, we try to, and I encourage others in our space to also remain controls agnostic. So like whether it's 0 to 10, dry contact, DALI, DMX, like whatever it may be, remain controls agnostic. And because we don't know what's happening in the control space as we progress. Like we're seeing this big shift, like or I guess like we're hoping to see a big shift from like 0 to 10 into things like DALI, into bus-based communications architectures. So we're not like limited by zone, right? And that's so like it's great to see that. So I think we don't right now. What we don't do is we don't send data along the power line. There may be a case to do that, but there may also be a case to maybe one day we do DALI over power line, or like I'm a big fan of keeping with the established protocols, like whatever it is, like BACnet, DALI, DMX, whatever the established protocols are, so that we can have an open and inclusive lighting controls system.
Right. But I mean, I think that the challenge here is the fact that, it's two changes that would have to happen. Is
Mm.
one, we would have to look at how the infrastructure of power is being done, but also then the infrastructure of lighting controls is being done.
Mm.
And, I see that being a couple of friction points. I don't see that as a reason to avoid it. I think this is a reason to encourage it, because I think that this sort of innovation is how we continue to stay current and competitive within an ever evolving market. But the challenge here is that, awareness needs to be brought. So, I think going back to Ron's question of, who should be targeted for this awareness and getting more up to speed on this. It sounds like contractors are doing a good job of getting up to date on this sort of thing. But, what about electrical engineers or architects or owners?
Yeah, it's a so you're totally right. Like with these changing technologies, especially with like the first adopters of LED, now, if not already, seeing the failures of their systems and having to refresh those systems, is thinking is like, okay, if we're gonna do this again, how do we do it right?
Mhm.
Yeah.
What do we do here? I think if I have to think of like how, well, I mean, like, hey, what we're doing here, like what you guys are doing, this is part of it too, is
Sure.
creating content. Yeah, creating educational content that's entertaining for people to consume. Hopefully, this is entertaining for people to consume and learn. I think the lighting agencies. I'm just thinking out loud here.
Yeah,
The
sure.
lighting agencies play a big part in this because they do all the lunch and learns, right?
Yes.
Like they're
Yeah.
a big part of the education, and so educating the lighting agencies so that they can also educate the specifiers, so the specifiers could talk to the architects and their customers and like
Mm.
to talk to everyone, and for people to reach out to the owners
Hmm.
and for the owners to seek out this information so that they can do a comparative assessment and to say, if I'm building a building, right, if I do it this way, this is what's going to cost, and if I do it this way, this is what's going to cost. That takes education throughout the whole value chain to be able to accurately price it, because if a contractor doesn't know how to price it, they'll just price it high.
Right.
Right.
And so it's a coordinated effort of education that has to happen on so many different levels in the value chain. It's not easy, and it'll take time, but I feel like that's part of my work as a DC evangelist is educating.
So if as people are looking at new buildings, right, and like, so where, I guess, where is sort of the divide line? Are you thinking people are going to go full DC, or is this still, we have AC power to power these certain things and we have DC for all of these things? How do you plan out what the future buildings look like?
Yeah, so for like the immediate future, it's hybrid, and so there will be AC systems and DC systems, and the when we're thinking class 2 low voltage, the AC systems feed those DC systems, right? Sometimes if it's solar, it's like the DC is feeding the AC system. Like it's a hybrid of voltages, of currents existing in the building. Some buildings, it'll make sense to do all the general area lighting, right? Some buildings, it'll only make sense to do the specialty lighting. So, for example, if you have a large complex fixture, if you have perhaps lighting that's in an inaccessible location, or somewhere that's humid, or an MRI room, or a clean room, or above a swimming pool, or above an ice rink, like things like that, there may be hybrid, even lighting systems where some are AC and some circuits are DC. I don't think we'll see a full DC, like everything, for another 10 years. Like I think that'll be like another 10 years before we see like it's a standard. It's becoming like you can build a whole DC building. I think for the next 10 years, between now and the next 10 years, it'll all be hybrid. And then eventually what you might see too is DC plug loads. So instead of seeing like the AC outlet, you might see USB-C only, and those are fed in the back end by DC powered. So it'll be some time before the code changes there.
Right, but I mean, I think, the infrastructure is growing in that direction regardless, because we're seeing laptops using USB-C as a
Yep.
charging source.
Yeah.
We're seeing pretty much, like, again, our sponsor MaxLight is using USB-C,
Hmm.
and
Yep.
so it is becoming a more commonplace resource. So having that, direct conversion to DC rather than having a transformer in the wall
Yeah,
like a receptacle, that certainly could reduce the pain points of implementing these kinds of resources while also providing a resource that people need.
for sure. And USB-C has uh, an interesting thing about it is that in the USB PD, the latest, it's 240 watts.
Hmm.
Mm.
So out of a USB receptacle, as long as you're using a USB cable, a USB-C cable, the proper one, you could get 240 watts, theoretically, maybe closer to 200 watts, but that's still a lot. Like
Right.
we're seeing
Yeah.
vacuums, right? Like the Dyson
Yeah.
vacuums are
Hmm.
Yep.
are USB-C. So there is a big push. I mean, like if you look at the biggest players in the market, like Signify tried this. They did it with PoE.
Hmm.
It didn't quite work the way they wanted, but they dropped it. Acuity has a DC to DC platform.
Hmm.
Cooper has what they call DLVP. I don't know if they're still doing much of it, but I know Acuity is their
Hmm.
DC to DC stuff. Um,
But I mean,
and yeah,
to your point, we're seeing it. It is
Right.
out
Mhm.
there, and there are definitely some people who were early adopters who tried some of these groups that folded, and unfortunately got burned as a
Mm.
result of that. But I think that's the other thing, is that we need sort of evidence of time that it really can be a sustainable business model. So
Yeah.
I think that's the other part of this whole education initiative, is to identify the groups that are still in the game even after years of implementing it.
Oh, that's a really good point. There's that. So like we've been around doing this for more than 10 years. And so like sticking with a group like a big reputable like Acuity, for example, like sticking with a
Mhm.
big reputable name that's been doing it, one. And then number two is because even a big company can discontinue product.
Right.
Yep.
So number two is like stick with a non-proprietary type of deal. So
Right.
non-proprietary wiring and non-proprietary control, and then that way, at least you could reuse some of that infrastructure, even if you have to
Right.
make a little bit of product changes. So
Yep.
there are ways to mitigate those risks, but those, yeah, for sure, those risks exist, and that's why we're in the early adopter phase of this
Right.
like adoption.
Well,
Yep.
we're almost out of time here, so I want to package this up because it's really interesting stuff that part of this whole transformative technology and disruptive design process that's being proposed with DC power is really incredible, because to your point, the vast majority of everything we're using electronic wise is DC powered.
Yep.
And so we have an incredible amount of waste by converting from AC to DC already. And then, it becomes that question of, okay, why do we have AC power to begin with in our buildings anymore? Because everything is converting to DC almost. And so, we're also seeing implementations of standards such as USB-C, allowing high wattages to be transferred from
Mhm.
a standard DC power source. But then the added benefit is that because it's DC and it's low voltage, that means that it's no longer needing these safeguards that are in place to prevent fires and shorts and everything that NEC is concerned about. And in fact, NEC is lifting restrictions by allowing more flexibility with what you can do, so long as you can guarantee that your safeguards are in place. You don't need that conduit. You don't need that all in box mentality. You can have your wires running in open air as opposed to behind some kind of shielding. Now, granted, there's always going to be a recommendation
Of
if you're
course.
in a sensitive area,
Yeah.
but
Yeah.
for the most part, most commercial buildings, for example, would benefit from this, at least on the checkbook. because they suddenly don't have to run as much copper, they don't have to run as much conduit, et
Mm.
cetera, et cetera. And the fact that when it comes to lighting and lighting controls, that infrastructure is pretty much already there. We just need to be able to utilize that. But the challenge is, getting it implemented early on in the design of a project, because you can't retroactively design it without it being an incredible process to then go through and say, okay, we're now taking out all of these breaker panels and we're replacing all of these branch circuits, and just sort of changing the structure and format of how you are implementing the power in the building. There is considerable time that needs to be dedicated to that regardless. So having it being a question at the beginning of a project is a really helpful tool for those who are at the seat at the table at the beginning. And if we're seeing again and again projects with tighter and tighter budgets, tighter and tighter timelines, and this is actually a way of accommodating those needs.
Mm.
And so it does become that question of, okay, why are we not seeing more traction with this? And again, I think there's a number of people who have horror stories with these sorts of experiences and technologies where it's like, yeah, we used brand wise DC system,
Mm.
and now we're stuck with a completely non-functional system because they antiquated it. And it's like, yeah, there's always that risk, but at the same time, if you stay agnostic, if you focus
Mm.
on the implementation so that it is accessible and replaceable by any other group, then you really aren't locking yourself in to be taken advantage of. You're enabling the project to take advantage of what's out there. And we're seeing more and more growth within this particular part of the industry. So odds are, if you stay agnostic and you pick a brand, if you pick product that allows you to swap with other products, there's going to be more available going forward rather than
Mhm.
less. And so it really, but it does require that mind shift. It requires
Mhm.
somebody to be able to go, okay, we're not going to do it the way we've always done it. We're going to have to change our mentality. We're going to have to think about lighting controls in a different way and building systems in general in a different way. But just like with anything, it's worth asking the question. And so I think, the more we get people asking that question, saying, have you considered a DC power system in your building? I can see, for example, like hotels.
Yeah.
Those would be one of the biggest benefactors, because if you have, USB-C ports in your room ready to go to power everything, great. You've got people who are like, yeah, awesome, I have everything I need right here. So, but at the same time, most building systems already don't need AC power.
No, for sure. It takes courage to implement
Mm.
that kind of change for especially the specifiers. Like
Yep.
kudos to the specifiers and to the owners for taking the risk there. And then I like what you said. There's also this piece of interoperability,
Mhm.
encouraging manufacturers to make things that are interoperable with one another, so that the power is in the hands of the specifier and the customer. They're not in a closed system.
Right.
Awesome. Bolis, fantastic conversation. Really appreciate you taking the time to talk to us.
For sure.
I love the ideas. The idea of getting rid of all these bricks and power supplies. I don't know about you, but any specifiers listening, I'd be more than happy to lose the brick that powers my laptop. If I could lose that weight from my bag every day, I would be a happy, happy camper, right? But like you said, there's so much waste, right? And it's all that. So market disruption is good, and it's what we need to make changes. So stay disruptive and let's get some work done, man. I love it. Thank you so much.
Yes. Right on. My pleasure.
Awesome. I'll just close this out and remind everyone today's episode is presented by the LCA, Lighting Controls Academy.
And is financially supported by the National Association of Innovative Lighting Distributors, or NAILD. Check out our website, lightingcontrolspodcast.com. Got all of our episodes and a whole lot more. But also, huge shout out to our sponsor for this episode. We cannot do this without your support, MaxLight and their CMax Lighting Controls platform. Speaking of market disruption, they are a market disruptor, and you should check out their products if you're unfamiliar with it. maxlite.com/CMAX. But thank you for joining us, And Bolis, thank you. This was an awesome conversation.